So let us solve these 4 questions by applying the Coulomb's rules. I gave you 2 formulas before for the Coulomb's rules. The first one I said is for free space. But if the medium is not free space, you apply the second formula. What are the formula? Let me help you to write it here. The first one is what? F was 9 multiplied by 10 raised to power 9 Q1 Q2 over what? R square. Whenever you are using this formula, the charge given is in what? On the free space. But if charge given is not on the free space, you will apply F 9 multiplied by 10 raised to power 9 Q1 Q2 over what? Relative permittivity times what? R square. This second formula is used for the what? For a medium, which is not a free space. Let's solve these 4 questions. It's not. Question number what? 1. Given parameter, the force on a charge. What the first charge? This is, call it Q1, 4 multiplied by 10 raised to power minus 10 Coulomb. Place 30 what? Centimeter from another charge. This. That is what? The Q what? Q2 is what? 5 times 10 raised to power minus 9 Coulomb. And the distance apart between the what? 4 and the 5 charges is what? 30. So our arc is what? 30 centimeter. Centimeter is into meter is 0. What? 03 divided by 100. So in what? In meter. Good. Find the word force. And look at the question here. They give us K. What is K given there? K is what? 9 times 10 raised to power what? 9 meter square per Coulomb. You can observe that what? They have make things easier for us. Find the force or the charge is. They don't tell us that what? The charge is in the medium, is in a free space, or the other was in the free space. But they make the question easy for us by giving us the what? The value for K, which is what? 9 times 10 to the power 9. And whenever you have using K for this, is a word in free space. So yeah, you can now use what? We use this first formula because we are given K here. We now have what? Using what? Force F was 9 times 10 raised to power 9 Q1 Q2 over what? R square. So what is my first charge given here? 9 times 10 raised to power 9. My first charge is what? 4 multiplied by 10 raised to power minus 10. Good. Multiplied by what? 5 times 10 raised to power minus 9. Everything over what? R. What is R given? 0.03 square. So by pressing the calculator, the final answer for F is what? 2 multiplied by 10 raised to power minus 7 Newton. So this is what? The force F we are asked to find in what? In question 1. The next thing is what? Let's go to the what? Question 2. In question number 2, we are given what? What is the force of repulsion between 2 equal charge 3 microcoulomb separated by a distance of 9 centimeters in a what? Vacuum. Here they tell you that what? The charge is in a vacuum. Vacuum simply means what? Free space. Abi? Good. So they said 2 equal charge, that is our Q1 here is 3 microwatt coulomb, and the second charge Q2 is also what? 3 microcoulomb. Check. They said what? Repulsion. The charge of the same kind, they will repel each other. Automatically, the charge will be what? The same. Two equal what charge? 3 microcoulomb. That is what? The first charge is what? 3 microcoulomb. The second charge is also what? 3 microcoulomb. Because they said two equal charge separated by a distance. What is distance between them? R is what? Is 9 centimeter. So if you convert, let me say R is 9 centimeter into meter divided by 100, you have 0.9 meter. So you are asked that what is in the vacuum. Since it's in the vacuum, is in the free space. We use this word, this first formula. By using the first formula, we have our F should be what? 9 times what? 10 raised to power 9 Q1 Q2 over what? R square. You now have what? The F force here. 9 times 10 raised to power 9 multiplied by what? What is the Q1 given here? Q1 is what? 3 microfarad means what? Times 10 raised to power what? Minus 6 multiplied by what? The Q2 times 10 raised to power minus 6. Everything over what? R square. What is R square we have here? R is what? Is 0.9. Is 0.9 meter. Everything what? Square. By press the what? The calculator. The final answer we have here, it should be what? 10 Newton. The final answer there should be what? 10 what? 10 Newton. So let's solve this third question. The third question. The third question said that what? Two charge plus 2 microcoulomb and plus 5 microcoulomb are separated by what? 25 centimeter. Good. What is the first charge given there? My Q1 there is what? Is plus 2 microcoulomb, and Q2 is what? Plus 5 microcoulomb. Abi? And don't forget, let me separate this. Q2 is plus 5 microcoulomb. This will be 2 times 10 raised to power minus 6 coulomb. Here plus 5 times 10 raised to power minus 6 coulomb. This microcoulomb means minus 6. By converting it, what will be the what? The distance given is what? 25 centimeter divided by 100 is 0.025. In what? In meter. And they said the part of the medium is what? You can see that this question is not from what? Free space, is not in vacuum, is in what? In medium. And our relative permittivity is what? Is 2.5 given. So what we use now? We use this formula. Using what formula there? Let us use what? F is equal to what? 9 times 10 raised to power minus what? Sorry, 9 Q1 Q2 over what? R square. Eat this. Substitute for each value here. The force will be what? 9 times 10 raised to power this. What is Q1? Q1 is what? 2 multiplied by 10 raised to power minus 6. Q2 is what? 5 multiplied by 10 raised to power minus what? 6. Everything. The relative permittivity given is what? 2.5 multiplied by what? What is R square? The R square is what? Is 0.25 square. So by pressing the calculator, not mistakenly, it will final answer for F is 0.576 Newton. That is what? The force here. So look at what? The question number 4. So you help me to what? To answer, to solve for question what? Number 4. We are given the charge Q1 to be this and the charge Q2 to be what? To be this. The distance apart is 0.12 meter. Find the what? Calculate the force between them. Look at this case. Yeah, they are not specified that whether the what? The charge is in what? In a vacuum or in the free space or in a what? In a other medium. So for this, at times, if you are given question that they do certify that is what is in a is not in free space, mostly of the question they always been in what? In free space. So you can use the formula for free space to solve this question and tell me the answer on the comment section. Yes, so like I said earlier, that you should help me to what to solve the question number 4 and put your answer on the comment what section. But the question, the charges, they are in what? They are in free space. But if it's in what? It's not in free space, they must give you the what? The relative permittivity. So the next thing is what? Let me help you to what? To add this to it. The effect of permittivity. The effect of what? Effect of permittivity. Please, I want to try to explain the effect of permittivity and magnitude of what? Of force. You know that I said permittivity describe the electrical nature of what? Of a material. So the effect of permittivity on a force, let me explain it here. We all know that what? From Coulomb's law. Let me say from what? From what? Coulomb's law. We know that force F is inversely proportional to what? The permittivity of a medium. Check this formula here. From this formula. Then now, from this formula that we have, F should be equal to the what? Let me say K, Q1, Q2, these are square. So from this formula now, remove the what? This. If we remove it, we have F proportional to the what? From the that's where I get it here. So if I remove the proportional symbol, we will have what? F should be, let me use what? The K over what? E have. Collect the like times. We have what? K should be what? F relative what? Permittivities of medium. Yes, from this expression, we can still have this as what? F1, this E1 is equal to the what? F2, relative permittivity of these two. Or we can have it in this form. F1, F what? F2 should be E2, permittivity of what? Of 1. But from this proportional relationship between the electric force and the permittivity of what? Of a medium, they are what? The force is the reciprocal of permittivity of what? Of medium. So from this relationship, this tells us that what? when the electric magnitude of the force is what? Increase. The relative permittivity of medium will be what? Decrease. Now this is what? The higher the what? Force. Magnitude of force is lead to the what? The higher magnitude of the force leads to what? Lower the what? Permittivity. Permittivity of what? Of medium. This statement can be simplified to what? That when the charge is placed in what? In a free space, the magnitude of the force that you obtain there, it should be higher than when the charge is placed in what? In a medium. Take for example now, let me use this example 3. Look at this example 3 here. Two charges +5, +2 and +5 are separated by 25 centimeters apart in medium. What is medium? 2.5. Determine the force. By determining the force in what? In the medium, we get this. If we determine the what? The force, assume, look at what? This force is when is in what? In what? In medium. Assume that what? This same question, these two charge, they are placed on a free space. Let us solve it. If you solve for the force when these two charge are placed on a free space, the force of repulsion, that the value of what? Force of repulsion as we find here, it will far greater than what? The force that we have in the medium. Because placing the charge in a medium, it reduces the repulsive or attractive force. But placing the charge in a free space or air, it will increase the what? The magnitude of the force. So the effect of the what? Of the permittivity in the what? In the force is the what? In order to reduce the electric force. To reduce the magnitude of what? Of electric force. Let's check this now. Let's solve this question. This same question in what? In this same question. Let's assume we have it in what? In free space. Q1 is what? +2 microcoulomb, which is what? 2 times 10 raised to the power minus 6 coulomb. Q2 is what? +5 microcoulomb, which is 5 times 10 raised to the power minus 6 coulomb. Abi, what is the distance? Distance is what? 25 centimeter, which is what? 0.0 what? Abi 0.25. Abi in what? In meter. But here is in what? These two charge, they are free space, which is vacuum, not in medium. So if they are in the free space, this relative permittivity 2.5 is not needed. My formula used will be what? K will be 9 times 10 raised to the power 9 Q1 Q2 over what? R square. If I apply this now, we have 9 times 10 raised to the power 9. What is Q1? Q1 is 2 times 10 raised to the power minus 6. Q2 is what? Is 5 times 10 raised to the power what? Minus 6. Everything over 0.25 square. If you press the calculator, the final answer we get here must be greater than what? This. So you may ask, what is the effect of a medium or relative permittivity or of a medium in electric charge or in electric force? It reduces the magnitude of what? Of force. So let's press calculator and check the what? The answer here. So if you press this, we have what? We have 1.4 Newton. Check it here now. Look at the distance. The final answer is what? 0 point what? 6. Here we have 1.4 Newton. So the effect of what? Of medium or permittivity on a force, on an electric force, is what? It reduces the what? The magnitude of what? Of electric force. You can see that what? The force of a charge in free space is 1.4, where the force of a charge in a what? In a medium is what? Is this. So the next thing that we are going to treat now is what? Is Coulomb's law in vector form. Coulomb's law in what? In vectors form. So this is the what? The Coulomb's law as regard as what? The Wahek, Jamb, and Jamb, IJMB, and other level. But the vector form of the Coulomb's law, we have it in IJMB syllabus, Jamb syllabus, and 100 level what? Syllabus. So the next aspect now is not meant for Jamb, for Wahek. It's for what? A-level student and 100 level student. Let me move up the board and move to the Coulomb's law.